Okay, here we go, sedimentary rocks. Let's start with this picture. What we have here, if you can see this is Cayuga Lake in upstate New York. What you have here, you see this river valley. This is after a heavy rainstorm, and you have so after a heavy rainstorm, what happened is it must have rained really hard the day before. Rained really hard, water hit the ground and went downhill into the stream. Now that water's flowing over the surface. As it does that, it picks up mud in the water. And then a lot of water goes in the river channel. So now the water's really rushing in the middle in the river channel. And it's also picking up a lot of mud that's normally at the bottom of that river when it's flowing slowly. So there's a lot of water in there. It's really rushing. So you have a lot of muddy water. And then it all goes out into the lake. So it's probably flowing pretty quickly because there's so much volume of water in the river. It goes out to the lake here. And what do you think happens to the speed of the water when it hits the lake? Correct. The speed of the water really slows down. So what happens here, and you really can see it, what happens here, if it's moving any big rocks here, they'll just kind of stop moving. But you really can see the fine mud is getting carried out. Like this is really the fine mud's getting carried out further to the center of the lake. This is probably like sand and stuff that's a little larger. It's probably being deposited here with the big pebbles here. So you really can see how the origin of these sedimentary rocks. It all starts out basically like this of some sort of sediment or rocks or pebbles settling down to the bottom of water. Okay. In this case, it's a lake. Mostly, it's the ocean. Most sedimentary rocks on Earth formed in the ocean because the ocean covers over 70% of Earth's surface. So most sedimentary rocks you find, almost all, were formed underneath the ocean. So what it is this. If you have this, please copy it down. Okay, sedimentary rocks are made of pieces of other rocks that settle to the bottom of the water. So you have to start out with a big mountainside or something, and then that big chunk of rock gets broken down into boulders, into smaller rocks, and then to rocks the size of your fist, and they become pebbles, they become sand, they become mud. Think of mud like clay would be the particles, and they will end up being your sedimentary rocks once they get carried to water. That's called clastic texture, made of pieces of other rocks or minerals. And examples of sediment are things like clay, silt, sand, pebbles, things bigger than pebbles, cobbles are the size of your fist, or even a little bit bigger, boulders. But boulders aren't really in rocks, but these are the main components of sedimentary rocks. And clay is, think of the stuff you play with as a kid. That is basically really, really fine sediment of clay minerals. So once they end up in the water, like I just showed, and then they will settle down on the bottom of that water, it's just, think of mud. It's just mud on the bottom of the ocean. It's just mud, loose mud. For it to become a rock, in that case, it would be shale, would be the rock that it would form. Two things need to happen to it. It needs to be compacted together, pressed together, and then something needs to keep it together. We say that being cemented. So it's oftentimes some kind of minerals that are in the water that will actually precipitate out of the water and cement those pieces, that clay, that sand, cement them together. So those two processes definitely need to happen. So that's the general, what people think of as sedimentary rocks is that clastic texture. Sandstone made of sand is a really good example of it. And you have chemical or precipitate sedimentary rocks. Now, this is a little more challenging and definitely not something that comes first to people's mind because it's hard for people to really see it. Most people haven't seen it. Is water has minerals dissolved in it. So all water, unless it's distilled water, but water comes out of your faucet, water you see in a lake has minerals dissolved in it. This water I have in this bottle, which I got from my faucet at home, there's minerals dissolved in it, and that's really what gives it taste. Some places have good water, good tasting water. Some water doesn't taste as good. It's based on the minerals in the rock. Now, they're dissolved in the water. Well, if the water evaporates, those minerals will go from being dissolved to being a solid. That process is called precipitation. Now, I know it's confusing. Precipitation, people think of rain or snow outside, but precipitation of the mineral from a liquid. And I wrote that here. If water evaporates or the temperature changes, the water becomes saturated with a mineral. Okay, so it can't hold any more dissolved minerals. And then, when saturated... Oh, boy. And then, you could pause this if you want. And then, when saturated, the mineral will go from being dissolved to a solid. And that is the process called precipitation of minerals from a liquid, as I just said. Rocks that form this way are called evaporites because it usually involves like having a lake or an ocean that kind of gets cut off, and then the water evaporating away and leaving the minerals behind. So evaporites or precipitates, and they have a crystalline texture. So this can be a little confusing because igneous rocks have crystalline texture because these minerals, when they precipitate out, they form slowly and they form crystals. So this can be a little challenging if you just have a piece of it. An example is, dolostone is an example, rock gypsum. Those are maybe not ones you're that familiar with. Rock salt, though, people can maybe relate to rock salt. It's when an ocean evaporates to salt water in an ocean of salt water, that all the water will evaporate away. And when the water evaporates, it's just pure water, H2O. Anything that's in the water, dissolved in the water, like the salt halite, will stay behind, precipitate out, and you can get really thick salt beds. And that's where we get a lot of our salt from. A lot of the salt that you eat, that's where it comes from. Some ancient ocean, hundreds of millions of years ago, evaporated, and that salt precipitated out, left behind. And you have that on your pretzels and stuff, so that's pretty cool. And we saw this picture before during igneous. This is a really good picture of a clastic sedimentary rock. Rounded pebbles, there's some sand in there, and it's cemented together. There's a close-up of this? Yes. Rounded pebbles, that's the key way to know sedimentary rocks such as this, and cement holding it together. You don't have the interlocking mineral crystals that you see. This is a picture of sandstone, and sandstone, I'm not sure how good this comes up in the picture here, it's made just that. It's sand that gets compacted, cemented, stays together, and becomes a rock. Usually, if you have this in your hand, when I say, "Oh, that's sandstone," you go, "Oh, I can see the sand now." You really, because it is very sandy. This is a close-up of it, of the actual sand grains. You see these little sand grains here, which are small pieces of quartz, usually kind of rounded from being in the wave action of a beach. And they get cemented together by minerals that fill in the gap between them, holding it together. This is a picture of rock salt, the crystalline, precipitate, sedimentary rock. And I guess maybe the thing that you're going to notice is to be different from an igneous rock. Monomineralic really is one thing that jumps out. But for kids in high school, telling something like rock salt from igneous rocks, because it's very crystalline texture, and it does look angular crystals interlocking, it is definitely a little challenging. This is it here, and you see maybe the angular interlocking minerals, but this is not an igneous rock, it's a sedimentary rock. So again, challenging. This is a chart if you're in New York State. This is the New York State reference table chart. And what it has, I separated them by colors. It has classic sedimentary rocks at the top, and it goes from large sizes to smaller sizes, texture, coarse texture to fine texture, the pieces that make it up. And this is your evaporite, your crystalline sedimentary rocks. This can be either, and this is bioclastic, which we're going to learn about. So what I did here is I have these rocks, and I took a picture of them. I don't know if anything's going to really jump out at you here that you're really going to be able to see. I have some other ones. Maybe this picture is better. No, maybe I have to look at this one. And maybe you can see this is conglomerate, brushed a little harder to tell, but you see some pebbles in here. It's pretty clear, cemented together. And then we're getting smaller here. We have sandstone. If you had these in your hand, it is very sandy and gritty. You can see the sand. So you actually see the sand grains here, especially if you look at it close with a magnifying lens. Then we get the silt stone. The pieces of silt is getting close, and that's getting close to mud. Okay, really fine pieces. You usually can't see the pieces of silt. And then you get down to shale, which is actually like really, really fine mud. Sometimes you'll see you have a puddle in your driveway, your house, and it'll be a puddle there, it rains really hard, and then it'll dry up, or close to drying, it'll dry up mostly, or the water's mostly gone, still kind of wet, and maybe you touch it and it's like super soft and squishy. That's usually like either silt or sort of clay that makes up shale. Really, really fine. It feels like velvety sometimes. Hard to think of it as like, oh, these are minerals, this is rock. But it is. And then we have rock salt. This rock salt here is kind of reddish. Rock gypsum is the mineral gypsum. Not very common to see. I will point out that rock gypsum is where they get sheetrock from. You know, sheetrock, wallboard. It's actually the white stuff in between. That's gypsum. They get it, they grind it up, and it's in the walls of most people's houses. And then we have dolostone, limestone, and coal, which we're going to learn about. Okay, sedimentary rocks. And so I like doing this. Is okay. We talk about the bottom of the ocean, and you go to the bottom. This sediment, we'll call it sand or the mud, gets carried out to the ocean. It will settle down to the bottom of the ocean and form a layer. It gets compacted. Well, it's going to get compacted by more. If it's mud at the bottom of the ocean, you have a layer of mud that's a foot thick, and then there's another layer of mud that's a foot thick, and then there's another layer of mud that's 2 feet thick, and that keeps happening. And finally, that first layer of mud may be under 1,000 feet, 2,000, 6,000 feet of mud. It is hard to think about that and how slow and how long that must take, considering that in some of these cases you have the mud builds up at that much a year or less. We're talking, the expanse of time is really, we're really getting into this huge expanse of time, and you just gotta like really try to think about it. So it's a huge amount of time, and then it has to get compacted by all the stuff on top of it, and minerals in the water will cement it together, and then you have layers of sedimentary rock. They're called beds. This is an example of it. This is in Texas, I believe, Big Bend National Park, and you see all of these layers. So these layers are deposited really flat in the bottom of the ocean. They will settle really flat. So this is maybe, I don't know, it's 100 feet, more than 100 feet. All this used to be under the ocean. So you hike to the top of this very difficultly, I'm sure, up this way. Up to the top, look all the way down and be like, wow, this used to be underneath the ocean. It's hard to wrap your brain around. Totally cool, but that's true. So that's a key part I want to make now. Okay.